Have you ever felt like time slows down when something incredible happens, or speeds up when you're lost in a moment? We've all said time flies or time drags, but what if those sensations aren't just feelings? What if they're hints that time itself isn't real? For over a century, physics has treated time as the steady background of everything, a river flowing from past to future. But recent quantum experiments are cracking that certainty open. They suggest time isn't a river at all. It's more like mist, something that appears continuous from afar but dissolves when you look too close. In 2019, a team at the University of Queensland ran a bizarre quantum test that flipped the usual logic of cause and effect. They used photons, particles of light, to perform operations where the order of events wasn't fixed. A happened before B, and B happened before A at the same time. It's called indefinite causal order, and it shouldn't be possible. Yet the math and the data confirm it. If the order of events can exist in a quantum blur, then before and after are not absolute. The universe might not flow through time. It might create time, locally, temporarily, contextually, depending on what's observed. Think about that. What if the past isn't behind us, but continuously rewritten by quantum processes right now? What if memory itself is a kind of illusion of continuity, a snapshot in a reality that never actually moves? Because in quantum mechanics, it's becoming clear. Time might not pass at all. It might emerge. And once you grasp that, everything, from free will to history, starts to unravel. So how can time, something we feel so deeply, be an illusion? The answer hides in the heart of quantum physics, where the rules that shape our everyday sense of cause and sequence begin to break down. In the classical world, time is linear. A cause comes before an effect. You throw a ball, it flies, it lands. But in the quantum world, particles don't obey that order so neatly. Their behavior is described by wave functions, mathematical ghosts that hold every possible outcome simultaneously. When unobserved, these possibilities coexist. Only when we measure them does one specific reality snap into being. Now imagine applying that logic not just to position or spin, but to time itself. What if an event doesn't have a definite before or after until it's observed? That's exactly what the quantum switch experiment explored. Researchers sent a photon through two operations, call them A and B. In one path, A happened first, then B in another, B happened first, then A. And astonishingly, before measurement, the photon existed in a superposition of both orders at once. This isn't metaphorical. It's mathematically verified. When you analyze the interference pattern of outcomes, the data match a world where A before B and B before A both exist, until an observation collapses them into one timeline. In essence, the photon doesn't travel through time. It participates in creating it. That discovery explodes one of our deepest assumptions, that the flow of time is universal. Einstein already hinted at this in relativity, that time bends and stretches depending on gravity and motion. But quantum mechanics takes it further. It suggests time might not be fundamental at all. Instead, it could be a byproduct of entanglement, of how systems become correlated through observation. Think of reality as a web of relationships, not objects. Each connection, each quantum interaction, gives rise to a sliver of temporal order. Add enough of those together, and we get the illusion of smooth forward motion. But remove the web, isolate the universe down to its raw quantum state, and time evaporates. What's left is a realm of pure potential, where the difference between past, present, and future loses all meaning. And here's where it gets unsettling. If the universe can exist in states where events have no fixed order, what does that say about causality itself? Could the future, in some sense, influence the past? Because if before and after can blur, then maybe time isn't flowing in one direction at all. But if time can run both ways, how would we ever know? Let's tear apart the illusion. You wake up, make coffee, scroll your phone, the minutes line up like dominoes. You believe you're moving through time, but quantum physics whispers something shocking. Maybe it's time that moves through you. Here's why that matters. Our brains evolved to organize chaos into order. To survive, we need sequences. First this, then that. It's how we track danger, tell stories, form identity. But beneath that psychological film strip, physics reveals something stranger. There might be no universal now, just localized snapshots stitched together by observation. Like frames in a movie, but without a projector. each one complete in itself without a real before or after. Julian Barber, a theoretical physicist who spent decades wrestling with this, calls them nows. Each now is a complete configuration of the universe, every particle, every photon, every field, existing timelessly. Our feeling of flow, he argues, is just our mind comparing one now to another. The brain creates continuity from static patterns, like a flipbook creating motion, and the quantum world agrees. When you examine a particle's state, you don't find it was here, then it was there. You find probabilities smeared across possibilities. The idea of an evolving state through time collapses. Instead, you get correlations between measurements. The particle doesn't travel. The universe just selects correlated frames when observed. That means the past isn't something back there. It's encoded in the structure of the present. Every memory, every fossil, every photon of ancient starlight is information now, not proof of something that was. The past is a pattern, not a place. Even the flow of time could be an emergent byproduct of entropy, the way information spreads and becomes less organized. As entropy increases, we label that direction forward. But nothing in the fundamental equations says it must move that way. In fact, the quantum laws themselves are time-symmetric. They don't care which direction you call future or past. The arrow of time, then, isn't written into reality. It's written into us. So, what if every possible version of the universe already exists? Every now frozen in a timeless quantum landscape? You aren't moving through those moments. You're experiencing one particular pattern among infinite ones, convinced it's part of a sequence. Because here's the paradox. If time doesn't flow, then your future might already exist, right now, waiting for the observation that brings it into focus. But if every moment already exists, who or what is doing the choosing? Let's climb the evidence ladder. 4 key steps that show how modern physics is dismantling our old picture of time. Step 1. Wheeler's delayed choice experiment. Physicist John Archibald Wheeler proposed a test so absurd it seemed like science fiction. Imagine you shoot a photon toward a beam splitter, a device that can make it behave like a wave, interfering with itself, or a particle, taking one definite path. Normally, you'd expect the photon to decide which behavior to take before you measure it. But Wheeler's setup lets you choose whether to observe it as a wave or a particle after it has already passed the beam splitter. The result? The photon's past behavior changes depending on your future choice. The act of observation doesn't just reveal reality, it defines it retroactively. Time, as cause and effect, breaks down. Step 2. The quantum eraser. Building on Wheeler's thought experiment, researchers actually performed it. When which path information is erased after measurement, the interference pattern, which should have vanished, returns. It's as if the photon decides what it was after the fact. This suggests the universe doesn't record events linearly. Instead, it keeps a kind of quantum fluidity until information becomes definite. No timeline until observation locks it in. Step 3. Indefinite causal order. We touched on this earlier, but it's worth emphasizing. This 2019 experiment by the University of Queensland used the quantum switch to show operations can occur in no fixed order. A before B and B before A coexist. This isn't an interpretation. It's measurable interference. In classical logic, that's nonsense. In quantum logic, it's expected. The universe might not have a master clock at all, just relationships that, when combined, give the illusion of progression. Step 4. Loop quantum gravity and emergent time. In the quest for quantum gravity, theorists like Carlo Rovelli propose that time isn't a fundamental ingredient. His framework, called loop quantum gravity, describes the universe as a network of interacting quanta of space. Time doesn't exist at that base level. It emerges only when those interactions are averaged over large scales. In other words, time is a convenient story told by macroscopic systems to make sense of microscopic timelessness. Each step adds weight to a radical conclusion. The universe might not evolve in time. Time evolves from the universe. What we call seconds and minutes might just be statistical illusions born from entanglement and entropy, an emergent property like temperature, not a fundamental one like energy. But here's the twist that no theory yet fully explains. If time emerges, what causes its emergence to feel so irreversible? Why can we remember the past but not the future? Because somewhere deep in the quantum fog, there might be a mechanism, hidden but real, that makes the illusion of flow so convincing we can't tell it's not there. And that's where the real shock begins. Because if we find it, we might uncover proof that the future already exists. If time isn't real, if it's something we construct, then every belief you have about your life, your choices, your destiny starts to tremble. Because without a flowing timeline, what is free will? What does it mean to decide anything if all moments already coexist? The shockwave begins with determinism. For centuries, we've swung between two views: the universe as a mechanical clockwork, where the future is set by the past, or as a chaotic, indeterministic playground of chance. Quantum physics seem to favor the latter: randomness, uncertainty, superposition. But now, if time itself is an illusion, both views collapse. There's no past that determines the future, and no future waiting to unfold. There are only timeless configurations, linked by patterns of correlation. Carlo Rovelli calls it the dance of relations. You and the universe are not moving through time. You are patterns interacting within a timeless web. Free will in this frame isn't about altering the future. It's about how consciousness navigates that web. Each observation, each act of awareness, crystallizes one possible relationship among infinite others. You don't cause change. You participate in selection. That reframes responsibility too. Your choices aren't launching effects down a timeline. They're expressions of a deeper quantum geometry already encoded in the structure of reality. In that sense, you're both the author and the text, the observer and the observed. Critics argue this borders on mysticism. Physicists like Sean Carroll insist time is real. Not fundamental, maybe, but emergent in a precise, measurable way. He calls the flow of time an approximate truth, like the smoothness of water hiding its atomic chaos. But others, like Barber and Rovelli, suggest the approximation is the illusion. The equations of quantum gravity don't require time. We add it because our brains do. This raises a disturbing question. If consciousness helps create the sensation of time, then what happens when we're not observing? Does the universe pause, waiting to be noticed? Or does it continue in some timeless realm where past and future are meaningless concepts, just coordinates in an eternal landscape? And if so, what we call the present moment might not be a fleeting instant moving forward, but the only thing that's ever real. Every second you experience, your childhood, your future self, this very breath, might exist simultaneously, forever. It means you never were born, and you'll never die. Those are just edges of perception, boundaries drawn in a reality that doesn't know what before and after even mean. But if everything exists at once, can the future be changed? Or is it already written in a language we haven't learned to read yet? If time isn't fundamental, then the technologies of the future won't just use time, they'll rewrite it. We're already glimpsing the first signs of this with quantum computing. Traditional computers depend on linear sequences, step 1, step 2, step 3. But a quantum computer doesn't process information in a fixed order. Its qubits can exist in superposition, performing operations that overlap in time and space. Researchers have even begun using the quantum switch to accelerate computation by allowing algorithms to occur in indefinite causal order. In other words, the computer decides after the fact which operation came first. That's not a programming trick. That's a small machine bending time. Now imagine scaling that principle up. If causality can blur, then communication itself could evolve beyond the arrow of time. Scientists are exploring quantum retrocausality, the idea that information could, in theory, travel backward through quantum correlations. In 2023, a paper in Physical Review Letters showed that certain entangled states allow measurement outcomes to be predicted as if information flowed from the future to the past. Not faster than light, but outside of normal temporal order. That could mean your future self could, at least theoretically, influence your present choices, not by sending messages, but by reshaping the probability landscape you inhabit. A kind of quantum intuition field. It sounds poetic, but it's grounded in math. Beyond computation, there's quantum simulation. Time crystals, structures that repeat not in space, but in time, were first realized in 2016. They defy the idea of equilibrium, oscillating forever without energy loss. If time can crystallize, it suggests temporal order can be engineered, controlled, manipulated. That means we might not just study time, we could build it. Artificial time zones within quantum systems, machines that experience their own tempo, detached from ours. And here's the wildest frontier: quantum gravity. If space and time are emergent, then manipulating entanglement could let us sculpt space-time itself. Theoretical physicists like Maldacena and Susskind propose that entanglement creates geometry. If that's true, controlling entanglement might one day allow us to fold or extend temporal dimensions, not with machines, but with understanding. Picture it. Laboratories where researchers design timelines, where cause and effect can be tuned like frequencies, where before and after are engineering parameters, not natural laws. But that raises a haunting question. If humanity begins to control time's illusion, what happens to meaning? What does love, memory, progress, even hope become in a world where later and sooner no longer exist? Because if we can shape time, we might erase the very thing that gives our lives a story. And the next discovery may force us to face that truth, not in the future, but right now. Let's bring it back to you, because all of this, the quantum equations, the paradoxes, the physics, ultimately points to one deeply personal question. What are you in a universe without time? You've spent your entire life feeling like you're moving, from childhood to adulthood, from mistakes to lessons, from dreams to memories. Your identity feels like a story, a sequence of chapters unfolding along a single thread. But what if that thread doesn't exist? What if you're not traveling through time? What if you are all of your moments, existing simultaneously? Think about it. Every version of you, the one watching this, the one you were 10 years ago, the one you'll be decades from now, might exist together, like pages already printed in a cosmic book. You're not writing the next line, you're reading it. Awareness flips through the pages, giving the illusion of motion. It sounds abstract, but we see echoes of it in neuroscience. Memory doesn't replay the past, it reconstructs it. Each time you remember, your brain rebuilds the moment from fragments of the present. The past literally changes depending on who you are now. That's not a poetic metaphor. It's measurable in brain scans. So even in biology, the flow of time is a story your mind tells itself to stay coherent. This also means the future you fear or hope for might already be part of the structure. It isn't waiting, it's there. You're just not tuned into that pattern yet. From the quantum perspective, every potential future exists as a wave function. Observation, your attention, your consciousness, selects which future becomes real for you. That's why this idea isn't depressing. It's liberating. If time is an illusion, then regret is too. The you who failed, who lost, who said the wrong thing, they still exist, yes, but so does every version who succeeded, who loved, who forgave. Reality isn't a single road, it's a timeless terrain, and consciousness is how you navigate it. You don't move forward, you shift focus. You don't grow older, you expand your awareness across more of what already is. And that brings us to something profound. If time isn't real, then nothing is ever truly gone. Every laugh, every touch, every thought exists, always. You're not a traveler passing through moments. You're the still point in a universe of infinite patterns, each one eternally now. But if everything already exists, every possible version of you, what exactly does it mean to change? Maybe what we call change is just waking up to another part of the same timeless whole. So here's where it all comes together. If quantum physics is right, if time is not a river but a mirage, then the deepest truth isn't about clocks or equations. It's about perception, about consciousness, about how reality reveals itself only when something, or someone, looks. Time, then, is not what separates the moments of your life. It's what connects them. Every instant you've ever lived, every decision you've ever made still exists, suspended in the fabric of a timeless universe. You aren't in time. Time is in you. That changes everything. You don't need to fear running out of time, because in the quantum sense, there's nowhere to run to. The version of you who's watching this isn't on a path that ends. You're part of an eternal pattern, a constellation of awareness that flickers through countless possibilities, giving each one meaning. When scientists say time might be an illusion, they're not denying your experience. They're showing that experience itself might be the most fundamental thing in the cosmos. Maybe consciousness doesn't emerge from time. Maybe time emerges because of consciousness. So the next time you feel that rush of not enough time, pause. Look around. This moment isn't fleeting. It's infinite. The universe, seeing itself through your eyes. Do you believe that time, as we know it, is just a projection of consciousness? Or is it a real force we simply don't understand yet? Tell me below. Your perspective might just change how someone else sees reality itself.